Hello everyone and welcome back. In today's video, we are going to be conducting yet another exploratory data analysis. And for this for this analysis, we are going to be doing an A/B testing. So basically, we do have, according to our data, you can see that this data is about campaign for Kindle. And as you can see, there are two campaigns in this data set. So campaign one, or the campaign one, Akin 9326, according to the description, we can see that for this campaign, it is persuasive ad that is focused on long-term benefits of reading in one's professional life and how Kindle can help with this reading. While campaign number two, this is focused on instilling fear in people's mind about what will happen to professional career if they don't read regularly. So these are the two campaigns in the dataset in this dataset, and we are going to be conducting an A/B test to see. So basically, that's the objective. So for our objective for this analysis will be about which ad campaign led to more conversions. So we are comparing these two ad campaigns basing on different types of metrics, and after that we can then draw some conclusions and determine which ad campaign had the most conversions. Okay, so basically that's what we are going to be doing for this analysis. Let me just so basically that's what we're going to be doing for this analysis. So just know this is an A/B test, exploratory data analysis, where we are going to between the two given campaigns, we are going to determine which campaign had or led to the most conversions. Okay, so that's it. So as usual, these are just the normal stuff that we encounter during exploratory data analysis. So the first thing, as you can see, this case is all about importing the necessary libraries. So the pandas, the numpy, the matplotlib, all that. So that's our first step. Then after this, usually the next step is all about importing the dataset. So as you can see, this is our dataset. It's just a short dataset. Basically, you can just use this information now. You can scale it depending on the type of data you are handling. Then you can also check the data summary. Also here you can just see that we have a total of 1250 entries in our data frame, and these are the column names. You can see we have a total of 10 columns, and you can also see the data types of the values under those columns. Okay, we can do some data cleaning steps. So for the data cleaning steps, we can start by checking for duplicates. For the data cleaning, let me just make this cell to be a markdown. So you can check for duplicates. So for the duplicates, df duplicated, and keep equals false. So keep equals false. Then you can run this and find the total number of duplicated rows in our data frame. So supposed to be duplicated. So you can see we have a total of 140 rows that are duplicated. So you can then just move a step further and dropping these duplicates. So we can drop these duplicates and make our data frame duplicates free. So for that, you can just repeat this process. So when you do that, you can see 1180. That means we have dropped the duplicates. Also, another thing under data cleaning is that I'm going to rename these columns so that we provide some descriptive names for these columns. So for that, I'm going to be using a dictionary. So I'm going to use a dictionary for renaming these columns. So the dictionary, I'm providing a key and its value. So the key will be the original name of the column or the attribute, while the value will be the new name that I'm going to be using to rename that column. So as for the other ID, you can just see that I'm just replacing that with this campaign ID, the same age group, gender, interest, all the way up to the last column, which is approved conversions. Then after that, we can just rename those columns according to this dictionary. Then when we execute this cell, you can see that we have renamed those columns. So for my case, I like using descriptive names for these columns because they, in some way, will try to tell a story. So we can then move on to another step. So we can see for our data, we can see we have different types of data types for the values in these columns. So for example, the first column, add ID, you can see that the data type for the value is an integer, while for the campaign, you can see it's the data type is an object. So for the columns of the attributes containing object as the data type, I'm going to print the unique values for the categorical columns so that we get to see what are the unique values in those columns. Okay? So I'm going to print that. And for that, you can see that the first thing is all about selecting the categorical columns. So I'm selecting the categorical columns from my data frame, and I'm using the select dtypes function. And inside the brackets, I'm passing in an argument, and this argument is include only the columns with object as the data type. Okay, then we'll generate something like a list for this, and that will be stored under the cat columns as my variable. Then we can calculate the frequency of the categorical columns in each column, because we want to determine something like the count. Then for this, I'm just creating something like a list. Then from that, I'm going to use a for loop that will be iterating over those columns. And while doing that, it will be doing the frequency counts for the unique values in those columns. And after that, we are going to print the frequency count for each categorical column that will be in this list here. So after that, we print this. And when executing this cell, you can see that we had 1, 2, 3, 4. I think there were 4. 1, 2, 3, and 4. So we had 4 categorical columns. So as you can see, we had the frequency count for campaign ID. This is the first one, age group, the second one, gender, the third one, and audience interest as the fourth column. And with each categorical column that had an object as the data type, you can see the unique values. So earlier on, we saw that we had 2 ad campaigns. So Akin 9326 and Akin 8012. So these are the 2 campaign ads, and you can see the count of the instances of both. Then for the frequency count at age group, you can see the different age groups, 30 to 34, 45 to 49, 35, 39, 40, 44, and the respective count of these values in the age group attribute, and so on and so forth. So you can see those the count of the respective columns in each numeric in each column containing object as the data type. So we can then move a step ahead and plot, let's say, plot pie charts so that we can see the distribution of the unique values under the columns which contain object as the data frame. So basically with this piece of code is that we are writing this code so that we can be able to print out pie charts for each categorical column. So when I say categorical column, I mean column containing categorical values object, in other words, a string. So we are going to plot pie charts so that we are able to visualize the distribution of the unique values under those columns. So the first thing is to have created a list of the unique a list of the columns which contain categorical values. So you can create a list like this, or you can just since this one also contains that list, you can just say, for example, cut columns. So let's do this. So we can say something like this: cut columns equals to cut columns, and let's make this as a comment. Then just print here cut columns. So when you execute this cell, you can see that we're getting a list, and this list is similar to this list. So depending on what you prefer, so you can decide to choose any. But for my case, I'll be just providing that list the way it looks. So I just provide a list of those columns. Then after that, we move on to calculate the number of rows and columns based on the categorical columns and the subplot per row. So I'm going to specify the number of columns for the plot. So as you can see, I'm specifying two meaning that the number of subplots for any given row. So row is like I'm moving from along is horizontally. Okay, so the number of rows now. I'm sorry. The number of columns. So I'm providing number of columns for every row. So that is 2 along the vertical axis. So the number of rows, what I'm doing, I'm performing some mathematical calculations. For example, I'm determining the length of the categorical columns. So that means we have 2, 3, 4. So we have 4 as categorical columns. Then I'm adding the number of columns minus 1. So number of columns, so I'm adding 2. Then subtract 1. So basically I'm just adding 1. Then I'm dividing that. I think by this, I think it's absolute. Then I'm not quite sure, maybe. But I think we're dividing without a remainder, something like that. So then we are dividing this by the number of columns so that we get the integer division to calculate the number of rows. So after that, we create a figure and a set of subplots. So figure and the axis. So we define that. This number of rows is simply this value, the value that we get from here. So we can also check, for example, if we type in number of rows. So let's see what we are getting. As you can see, we are getting 2. So that means length of categorical columns. You can see that 1, 2, 3, and 4. So that is 4. Plus number of columns is 2. So 4 plus 4, that is 2. 4 plus number of columns, that is 2. Okay. 4 plus 2, that is 6. 6 minus 1, that is 5. Divide by the number of this. You get 2. You get so I'm going to get an integer division. So that is 4 plus 2, that is 6. 6 minus 1, that is 5. So when you divide 5 divided by 2 as an integer division, I'll be getting, when you divide that, you get 2.5. But I'm only interested with the integer, the first digit before the decimal place. So that's why 5 divided by 2, that is 2.5. So I'm interested with that number too. So that this is the result we're getting. So that means we'll be having the number of rows will be 2 for this case. You can just do away with this. So basically, you can now see the calculations. Then after that, we can use the for loop to iterate through each categorical column. And while doing that, we're going to plot the pie charts. So for I column in enumerate columns, then by this we select the subplot based on the index. Then we plot our pie chart. Then we set a title for the subplot. Then to hide any unused subplots, so we use this piece of code to hide any unused subplots. Then we can plot our chart. So these are the plots, the pie charts for the different categorical values for the categorical columns. So as you can see, for Akin we have those two. You can see that for Akin 9326, when we do a value count, you can see that the Akin 9326 accounts for 53.1% of the total values under the column campaign ID. For gender, 51.9% are of the male gender, while 48.1% are of the female gender. The same for the age group and same for the business and industry. So we can visualize the distribution of the unique values under columns with categorical values. So this is the plot for that. We can also do data distribution for, say, data distribution for numeric columns. So for the numeric columns, this one will use histograms. So df.hist, bin 75 figure, this one, then we just plot. So when we execute this, you can see the distribution of the values in the numeric columns. And for the column add impressions, you can see this long tail on your. So basically, you can say from this distribution, no columns under no numeric column follows data in a normal distribution. Okay. So that was a data distribution for numeric columns, and this was a data distribution for categorical columns. Okay. So basically, I think you now have some brief overview from these charts. You can now picture the data that we are going to be handling. So there's one thing that I need to check, and this is about, since this one is an A/B test, remember we are comparing two campaigns, that is the Akin 9326 and Akin 8012. So if you're going to make this comparison, then we definitely need that we should at least have almost the same instances of those two campaigns. And so I'm going to do chi-square test so that to determine if we do have, or to determine if the count of the unique values under the said column, if there is some sort of significant difference. If we find a significant difference, then we need to do a resampling such that at least we have equal instances. But if we don't get any, or if we don't get any, if there is no significant difference, then we will just leave. We won't need to do that resampling. So we can do a chi-square test. So chi-square test, test if So here we are trying to test if there is a significant difference. So that's what you're going to be testing. Test if there is significant difference in unique instances of the two types of campaigns. Okay. So from this, I'm going to start by importing the chi-square module. So from py.stats import to contingency. Getting contingencies. Okay, that's okay. Contingency. Then after this, I will be creating a contingency table. Contingency table. So this is a PD. Using the cross tab function, cross tabulation, something like that. Cross tab. Then index for our data frame. So we are going to be looking at the column campaign ID. Basically looking at the account. So column count of the unique values. Then after that, we perform the chi-square test. Chi-square test. So I2 the p-value. Then these other measures we won't be needing them. So this one will be now we recall our function. So this one, to contingency, and inside the brackets we pass in this contingency term. So after we have performed our chi-square test, we need to print the chi-square test results. Print the results. So the results will print. I'll use an f string, so f chi-square statistics. For the chi-square statistic, this one we just provide so chi2. So this one here, this, and for the p-value again print. F going to print, that is f, so p-value, and for the p-value so p we're getting some error print chi-square statistic. We are getting some error somewhere. I think this one should be like this. All of this should be inside the brackets. That's okay. So you can see that this is the getting a chi-square statistic of 0.0 and the p-value of 1. So after this, we can determine significance based on the p-value. So based on the p-value, so here we are going to state our alpha. So alpha is equals to 0.05, so meaning at 95% confidence level. So if the p-value, let's say it's less than or equal to alpha, then we can print a statement saying that there is a significant difference between the categorical categories in the campaign ID. Okay? But if that is not the case, then we can print the statement. Supposed to be else. We are going to print it will be just the same statement. Print there is just use an interjection, something like a no. So when we execute this again, you can see that there is no significant difference between the categories in the campaign ID column. So that means we are not going to do a resampling, so that we at least get equal numbers or equal instances of both campaign IDs in our data frame. Okay. So after this, there are some we can also do feature engineering. So with the feature engineering, what we are going to be doing is we're going to be adding other columns. So adding other columns based on the columns we have. So we are based on the columns that we do have, we are going to either divide them, we can add, combine, so that we get other columns, which will be also important when determining the best campaign ID, the best campaign for this model. Okay. So the first one that I will be doing is about adding the click-through rate. For the click-through rate, we can just here we can divide. We can divide the add clicks, and we can divide the add clicks and add impressions. Believe so. Let's say click-through rate. Formula for this: clicks divided by impressions. So for the click-through rate, we can divide the add clicks and the add impressions, so that we obtain a new column, and this column will be the CTR, click-through rate. So we're going to calculate that. So calculate click-through rates, and here in some of these columns, you can see some of these columns. Let's print the first 30 rows. You can see that in some of these columns we do have zeros. Okay, and you know, when we are going to divide a number with a zero, or if we have zeros as part of the divisions, either the numerator or the denominator, we might want to at least we might get errors. So that means we need to check for those errors. So here we are going to calculate the click-through rate while also handling the division by 0. Okay. So to do this, so it's under our column, we're going to create a new column, CTR, so for the click-through rate. Then np dot where. So I'm going to specify such that if we do have a column that has zeros, what we are going to be doing with that. So for this, remember we are dealing with the column add clicks. So add clicks. So in an instance where the add clicks is equal to 0, okay, and I think clicks equals to 0, close this bracket like this. So this one is closing this. We don't need this one. So this one closed by this, and this one is okay. So in an instance where the add click is equal to 0 and another column in the column add impressions, is also equal to 0. So what we are going to be doing is that we are going to replace this with nan. So np dot none. So basically with this code snippet is that it will be checking if either the add clicks or the add impressions is 0 for each row in our data frame df, and if either of them is 0, so if add click is 0, if we encounter a value where it's 0, or the add, or in the add impressions, if we also encounter where the value is 0, it is going to replace the click-through rate value with an NaN, meaning that not a number. So by doing this, we'll be handling the division by 0 errors and set the NaN for rows where either the number of clicks or the number of impression is 0. After we are done with this, we can then do the division. So df then add clicks. After this, then we are going to divide this by then df add impressions. Then you can multiply this by 100. So df dot head. So let's see if you're going to get something. Okay, now you can see, let's do for the first 15 rows. So you can see, for example, we had add click as 0 for this add ID. So with this, then we replace this value with NaN so that our critical values, the click-through rate, so the final value will be NaN, not a number. Okay. So by this we handled the division by 0, so that we won't be getting errors for that. Okay. So another column that we are going to add is the cost per conversion, and similar to what we did earlier, we are going to calculate the cost per conversion And by doing so, we are going to be handling the zero errors. So with the cost per conversion, we'll be dealing primarily with the add expenditure column or attribute and the approved conversion attribute. And again, similar to what we did earlier, we're going to specify that in an instance where the add expenditure is 0 and the approved conversion is 0, we're going to replace those values with the NaN to simplify those are not a number, so that we won't encounter any errors when it comes to division. And with that, we will be dividing the add expenditure and the approved conversions. So when we execute this cell, you can see that the cost per conversion, then you can see that we are getting the NaNs. Okay. So another column is about the conversion rate. I also think that is also an important metric that we can include, basing on the type of columns we do have in our data. So we are going to determine the conversion rate as well as handling the zero and handling the division by 0. Similar to what we did earlier, we're just going to repeat the same, in that we're just going to change the names of the columns, because each calculation involves a set of different columns or attributes. So from this analysis, from this feature engineering, you can see that we added the click-through rate column, the cost per conversion column, and the conversion rate column. So we have added more metrics, and with these metrics, we will be and basing on the results from these metrics, then we can successfully be able to group those campaigns and determine which campaign was successful, or which campaign can be successful. So after we have done the feature engineering, I usually consider the feature engineering to be part of data cleaning. So data cleaning is just removing inconsistencies and trying to position the data in the best fit possible, so that when you are doing the EDA, you are going to get credible results, accurate results from your data. So I think we are done with the data cleaning steps or procedures. Then we can move on to the main agenda, which is the exploratory data analysis. So now let's begin tackling the elephant in the room. So I'll start with the describe method. So with the describe method, you're going to be getting a descriptive statistics basing on the numeric columns in your data frame. So you can see the count in each and every column, the mean, the standard deviation, the minimum value in each column, the 25th, 50th, the 75th percentile, the maximum value, all that information you are going to get from this. Then these are just the descriptive statistics. They just maybe inform you on the descriptive nature of your data, for lack of better word for that. So these are you can see your data according to these descriptives. Then you can then move on to I want to plot a box plot, so that we are able to visualize. So I'll consider the approved conversion as my target column for this analysis, because eventually after doing this, after structuring your ads and you have selected a demographic and you've sent your ads out there, then basically you need to get a response from your ad campaign. So after the campaign, the response or the success of your ad campaign will depend on the approved conversion. So so with that reason, with that justification for that, then I do consider that the approved conversions will be the target variable. So you want to see, basing on your campaign, how many conversions or the approved conversions am I going to get from each campaign. So I'm going to plot a box plot for this, such that we're able to see the approved conversion for the box plot. I'm going to compare that with the categorical columns in the data frame. Okay. Then for the numeric columns, these numeric columns, we can just plot, or we can just do a correlation analysis, and then see how the numeric attributes are correlating with the target variable approved conversion. So for the box plot, so I'm going to so for the box plot, this is the box plot. So the first thing that I'm doing is setting the figure size for the plots. Then we set the categorical columns excluding the product ID, not the product ID, the add ID. This code I just lifted it from somewhere else. So from the add ID from the data frame, for column deselect object columns if column, so we are excluding the add ID column. Then we are going to be looping through each categorical column for plotting, and we use the enumerate function, and then we create the subplots with the 2 rows and 3 columns and an index a plus 1. Then we create a box plot with the different with x-axis as the current categorical column and the y-axis as the approved conversions. So also here you can, I think this okay, then we can set the title for each. Then when we execute this, you can see this is the box plot, and from the box plot you can see how the different categorical values are matching up with the approved conversions. Okay, so even you can most of this you can see that the median of the mode are quite the same. Okay, but basically this is the box plot, and from the box plots you can also see how these columns are correlating with the approved conversion. So for the numeric columns, we can plot a correlation matrix. So for the correlation matrix, basically we start by filtering out the numeric columns. Again, we are going to exclude the product supposed to be add ID. Then calculate the correlation matrix. So this is the correlation matrix. This is the correlation function for that. Then we plot the correlation matrix as a heat map. And then from the heat map, you can see how the different columns or attributes. So for main column, this is the approved conversions, this column here. And as you can see, for the add impressions, add click, and add expenditure, you can see it's about 0.4 correlation. But for total conversions and approved conversions, you can see there's a 0.6 correlation. So basically, as the total number of conversions increases, so does the approved conversions increases. Then for the click-through rate, you can see there's a negative correlation. So there is an inverse correlation between click-through rates and the approved conversions. For approved conversion and the cost per conversion, there's almost zero correlation there. And the conversion rate, you can see again there's a minus a -2 correlation for that. Then you can see that for the approved conversion and the conversion rate, so there is an inverse correlation in that. As one increases, the other one tends to decrease. So after we have done all that, this charting to see all that, then we can start doing the analysis part, where we do some comparison here and there to try to find out the performance of these ad campaigns based on the different metrics that we select. So we are going to start with the campaign ID. So for the campaign ID, let's start from here and compare the campaign ID based on these metrics. So campaign type, so df.group by, we are going to group it by going to be grouping that by campaign ID. So campaign ID, then the other metrics, so the metric that you're going to be using, so I'll just provide something like a dictionary for that. Then list all those. So for this, for the campaign type, then we can determine, so we are going to sum so that we determine the total ad impressions for both. Then for the ad clicks, we again sum for the click-through rate, we can just find the mean, cost per conversion, the mean, and the conversion rate, we can also determine the mean for that. Then for a little bit clarity, I'm going to rename these columns. But before that, we can say reset index. Because we're generating a new series, then we need to reset our index. Then we can rename the columns for a little bit more clarity. Then when we execute this cell, we are going to get the results comparing the campaign ID. So campaign ID, we're getting an error for this. I think it's supposed to be captcha. So so this is the new series that we are generating, and you can see for the campaign ID, we have those two campaigns. So campaign Akin 8012 and Akin 9326. So from this, you can see that the total ad impressions for the campaign Akin 8012, you can see it's about 34 million ad impressions. For the other one, you can see it's 20 million ad impressions. For the total clicks, you can see if you're going to have total ad impressions, then the total clicks, we are also getting a high number of total clicks compared to that. So we can also just provide insights for this. So for the insights, you can say that you can see that campaign for the campaign ad, you can see the total impressions, the total ad clicks, for the expenditure, for the total conversions, for the total approved conversions. We can see based on these metrics. So we can just copy this and say campaign ID Akin 9326 9326 is best. I say ranks top in total ad impressions, total ad clicks, total ad expenditure, total conversions, total approved conversions. Okay. Then Akin 9326. So when we look at the average control for the average cost per conversion, the conversion rate, so as we look at the average click-through rate, so if let's say What does it mean if the click-through rate high click-through rate is a good indication that users find your ads and listing helpful and relevant. So if you're going to have a high click-through rate, it means that it's a good indication that the users find your ads and listings helpful and relevant. So let's see. This one for Akin 8012, we have maybe because they're versioning ads, they're going to get a higher click-through rate. You can see it's about 0.2 and 0.1. For the average cost per conversion, costs, so high cost per conversion. So what does a high cost per conversion? A high cost per conversion clearly indicates that obtaining a real customer is getting expensive. So in terms of the average cost per conversion, you can see that. So our insight here, you can say that for campaign ID Akin 9326. Let's say use the other one. So Akin 8012, you can see that it has the highest click-through rate. Lower cost per conversion. As a lower cost per conversion, that means it is less expensive to acquire a customer. And for, let's see, for high conversion rate. For higher conversion rate, meaning is that the higher the conversion rate, the more effective your content, or the more effective your ad. So you can maybe use this. So let's say higher your conversion rate, the more effective your ad campaign, because here we are dealing with the ad campaign. So also a high cost of conversion indicates that the obtaining a real customer is getting expensive. So here we prefer a lower. So here you can say we prefer lower, higher conversion rate. Here we prefer lower cost of conversion. Then we have done another thing, click-through rate. So high click-through rate. So the click-through rate, we can also, let's say, add another high click-through rate is a good indication that the user finds your ad and listing helpful and relevant. So here we prefer high CTR. Let's call it like that. So for the total ad impressions, so you can also say higher ad impressions. So an increase in your so if your ad has 1,000 impressions, that just means it was displayed 1,000 times. Doesn't necessarily mean 1,000 different people saw it. But if your ad has a reach of 500, that tells you that 500 unique individuals have seen it and are potentially interested in what you are offering. Mm. So I think ad impressions is not quite a good metric for that. So we'll focus on uh, higher ad clicks. So that will be a good. Uh, so what higher the higher the ad clicks, the more successful the ad. Okay. So we can also add this one here. So the higher the higher the higher the ad clicks, the more successful the ad. So basically here we prefer higher ad clicks. Another one is the total expenditure. So for the total expenditure, this is self-explanatory. Here you can just say prefer less expenditure. So the total conversions, we prefer higher. Total approved conversions, we also prefer higher. Total conversions and total approved conversions. So here we prefer higher. So here we prefer higher values. Okay. So these are the metrics that we are going to be using for this analysis to compare the effectiveness of our campaign. So I think we should have started with this. Then we execute this code so that we are able to see how the this campaign ID, the campaign types are performing based on these metrics, and then we can then provide some insights to see which campaign is performing best. So earlier on, we saw that though we have included it, I'm not going to use the ad impressions because I feel it's not giving a better measure for campaign performance. So we'll just use the rest. So for campaign ID Akin 9326, so total ad clicks. So if your campaign is majorly focused on the total ad clicks, so you just want your potential customers to able to have more clicks in terms of views, then you can use this metric. Total ad expenditure, you can see that for Aki 9326, you can see no, this one is this one is 9827. This one is 500 and 557 point. No, this one is 55,000. This one is 9,000. So you can say campaign ID rank stops in total ad clicks, in total ad expenditure. So we have spent more in terms of running this campaign. In terms of total conversions, you can see it ranks higher in terms of total conversions, and in terms of total approved conversions, it also ranks higher. In terms of the average click-through rate, so we need for the average click-through rate, we need to prefer a higher click-through rate. So campaign Akin 8012 has the highest click-through rate, lower cost per conversion. Then we can also see in terms of conversion rates and the cost per conversion. You can also see in terms of conversion rate, we also prefer a higher conversion rate. So Akin also has ranks highest in conversion rate, and also I think it ranks higher average cost per conversion. Since we prefer, we need the cost per conversion to be lower, so it ranks higher in cost per conversion. So earlier earlier on we said that the approved conversion is the target variable. What we are focused more on this campaign. So for the total approved conversion, we can say that Akin is performing least in terms of this metric, in terms of the approved conversion. So in terms of total approved conversion, though the campaign is quite expensive, we are getting more conversions based on the Akin 9326. So depending on the goal of your ad campaign, because I do understand that different campaigns do have different targets. So some will be about, even some will be about just the total impressions. Some will be about the clicks. For example, in YouTube, maybe you want to have more clicks to your video. That means you have more viewership. In terms of expenditure, at least you want to keep your cost very low. In terms of conversions, you want to keep your conversions very high. Total approved conversion, then you want to keep this high as well. As we saw this one, you want to be at least get a higher value for that. So if we were dealing with a campaign and we wanted the best, we want the least average cost per conversion, then the Akin 8012 will be our type of campaign. Okay. Again, if we needed average conversion rate, then Akin will be the type of ad campaign that we are going to be using. But if you want in terms of total conversions and total approved conversions, then the Akin 9326 will be your campaign that you will be using. So those are the insights that we can obtain from that. Okay? So it has been a lengthy, but I think we do have exhaustively analyzed that. So we can go ahead and plot a bar graph for this. So we can plot a bar graph so that we can be able to visualize this information. When it comes to visualization, we can see that this is the visualization part of it. So we can see plotting a grouped bar graph. So when plotting, for me, I like using Plotly because I think it gives you much control in terms of how you can, in terms of maneuverability for your charts. So for example, for this, you can see that if I want to compare the total ad impressions, so I can just click on this and they will be deducted from the chart. So it only remain with one metric, that is the total ad impression. So if I want to move to the next, I can just do the same, click this, it will be deducted, and then I can remain with the other one. So based on the metric that you're trying to test, the different campaigns, then you can just deduct the other metrics, then remain. For example, if I just needed the total conversions, then I could just do this, then I could try to download this. Where this one, get access, and try to download this chart that only contains the total conversions. Then you can, when it comes to doing some presentation, then you can do that. So when it comes to, for example, if you want to compare between the total conversions and the total approved conversions, then you can just do the same and compare those metrics. So this is just a visualization of what we saw earlier. From this visualization, you can now able to see how the different campaigns are performing based on the metrics that we decided to select on. Okay, so that's for that. Then we can also do another comparison. We can do another comparison where we compare, let's see, in terms of age, okay? When it comes to age, we can do the same. So you can age, then group by age group, approve. I'll do away with ad impressions because we saw earlier that it's not going to give us what we need. So and then we can just add, let's add one of these. Click-through rate, let's just add all of them. There's no need to be selective. Let's add this click-through rate, this one. So CTR, from average CTR up to conversion rate. I think that's it. So for this, we are going to add them here. And for the total ad impressions, we're going to deduct, move this. So when you execute this cell, you can see how the different age groups are performing based on our metrics. So when it comes to total approved conversions, we can see that the leading age group is the 30 to 34. You can see 267 total approved conversions, followed by 169 for the 40 to 45 age group. Then to the 162 for the 30 to 35, then 40 to 45. So you can do that comparison as we did earlier. So you can then plot a graph for this. So when you execute this, then you can now see how the different metrics are performing based on the different age groups. So when it comes, for example, to average conversion rate, you can see how they are performing. When you're comparing the average conversion rate and the cost per conversion, then you can see that for the 30 to 34 age, although we are getting a higher conversion rate, the cost per conversion is quite low. Then we can see what you can able to see for this case when we are comparing the let's just compare the conversion rates and the cost per conversion for 35 to 39. You can see that we are getting 70 is about the average conversion rate, and the conversion rate for this in terms of the cost is about 47.84. Okay, so we can compare this with the total approved conversions. Then you can see how the different metrics are performing. Then from there you can just give a report based on the metrics that you are assessing. Okay, so here we are comparing the total approved conversions. So if we compare the total approved conversions with the average cost per conversion, then you can see how they are performing. Age 45 to 49, we can see that we are getting it has the highest cost per conversion, but when it comes to now the approved conversion from that, you can see it's the second one. I think so, 169, 162. Yeah, it's the second one for that. We can see that in the 30 to 34, it has most of the total approved conversions, but when we look at the average cost per conversion, you can see that when we look at the 30 to 34 age group, then I think we can see what we are performing in terms of the campaigns for this age group. You can see that it's performing well. We have the highest number of total approved conversion, but at the same time, we are trying to keep the cost per conversions to be quite low. Okay? So that's about it. Then in terms of ad clicks, so you can add this slowly by slowly, and then you see for the ad clicks and the ad expenditure, you can see. So if you want to see the ad expenditure and the total conversion, and for example the total approved conversions. So you can see the ad expenditure. The ad expenditure is also quite high for this, and as we saw, we were getting the most approved conversions from this. Okay, but the expenditure is high. But this one, the expenditure is the highest, but it was second in terms of total approved conversion. So basing on the metrics that you decide to pick on, then you can do that. So you can just maybe narrow down. So to cater for this analysis, where I selected the total approved conversions to be the target column. So for that, you can campaign by age, then campaign ID, age group, approved conversion, then you can just do the sum. Then when we do this, and then plot the bar graph for this. So for this instance, instead of just comparing the age groups, so earlier on, as you can see, we didn't have the column ID. So we're just comparing the metrics in terms of age. So here we are comparing the metrics age, but we also need to see how the two campaign types are performing based on the total conversions for the different age groups. So the age groups are listed here. So when we only look at the age between 30 to 34 and compare the two campaign types, you can see that generally Akin 8012 performs best in terms of the total approved conversion when we look at the age 30 to 34 than the Akin 9326. For the age group 35 to 39, 40 to 45, I think so, and 50, also this one. So maybe the insight here, best. So the insights. So as I said, my insights is all about total approved conversions. So based on total approved conversions. So insights based on total approved conversion, we saw that Akin 8012 performs better. So age group 30 to 34, and you can say that Akin 9326, you can see that it performs better for age groups 35 to 39, 40 to 44, and 45 to 49. So that's the insight we are able to draw from this. You can see that based on total approved conversion, you can see that how the different the different ads perform for the different age groups. So generally, you can see that this one only performs better for age group 30 to 39, but Akin 9326 performs better for these age groups. So generally, from the look of things, you can see that Akin 9326 performs better for this age group. Again, the total approved conversions by gender. So earlier on we did the total approved conversions by group. So let's before we do total approved conversions by gender, let's see again how the gender performs. So I'm just copying that. Then instead of age group, change that to gender. These other metrics will remain the same. There's no need for changing that. So this one will remain the same, age group, and just change this to age group. Then this one can rename gender. Then you can rename gender, and also you can rename gender. So gender and the different evaluation metrics, so male and female. So you can see in terms of total ad clicks, men were leading. In terms of total ad expenditure, you can see it was highest for the female. In terms of total conversions, you can see that the women are doing the most of the conversions, while it comes to the total approved conversions, again the female gender. In terms of average click-through rate, so we wanted the click-through rate to be high. So you can see that it is high in the female. When it comes to the average cost per conversion, it's high in female. So it is cheaper acquiring a male client than a female client, something like that. For the average conversion rates, you can see that we need a higher conversion rate. I think so. Or am I missing something? When it comes to conversion rates, we prefer higher conversion rates. So in terms of the conversion rate for men is high. So men lead in terms of conversion rate, in terms of cost per conversion because it is very low, but they lag in terms of the click-through rate. We want a higher click-through rate. We want, in terms of approved conversions, we want higher conversions and all that. Okay. Again, you can plot a bar graph for this. So this was just a bonus, something like that. So you can say, not this one. I took the wrong one. So this one. You can copy this and just paste it here. Then we are dealing with the column gender. So age groups, change this to gender. And I think no, age is supposed to be, change the age to gender, while the x-axis will be this one, the gender. So when we execute this again, you can now see cost per conversion. No, let's do a cost per conversion and the conversion rate. So in terms of for the female, you can see that the average cost per conversion is high, and the conversion rate is that they're almost the same. So average conversion rate is this, and this one is the cost per conversion. So we are converting high than the cost. So we need to maintain the cost of conversion to be low. So you can see for the female gender, the average cost per conversion is higher than the conversion rate. So it's quite expensive to acquire a female client than a male client. So you can obtain that from that. When it comes to total approved conversion, and let's say ad expenditure, although with this one we already discussed. So total approved conversion, and these two, you can see that despite this indifference, we can see that we generally got, so despite the cost per conversion for the gender female to be high, you can see that despite that we got more clients, female clients than male clients. Okay, so analyzing that in that perspective, then you are able to see the insights that we can generate from these charts. Okay, I do like the visualization charts because just by visually seeing what is happening, you're able to deduce these conclusions. It's very easier when you're using these charts. So that was all about this ad performance metrics with gender. But now let's see which campaign ad performs best. The total approved conversions with gender. So this one we're just going to tackle gender in terms of the campaign ID itself. So gender group by gender and campaign ID, then a total approved conversion. So it's not different from what we did earlier. Then we can just directly plot a chart to see. So in terms of the Akin 8012 and Akin 932, so we can see that in terms of total approved conversion for the male, we can see that it was total approved conversions was higher for the Akin 32. So let me copy this inside. So this one. So this is the major objective for this study. So that's why I'm only providing insights based on the total approved conversions. So you can provide insights based on the number of clicks or based on the cost per conversion, based on the expenditure. So it depends. So I've just selected one evaluation metric so that it can be the guiding principle for this analysis. But depending on what you'll be solving for, that will be your overall target or objective for the given analysis. So Akin 80 performs better for the, so here we can just change this. So Akin 8012 performs poor for both gender, for the male and the female. Okay? In terms of the total approved. So for female, for the total approved, again you can see both gender. So I think better for both gender. Just the difference of the previous one. So you can see that for Akin 80, in terms of the female, we had 163 conversion. 163 conversions. And then Akin, this one, 163, 127. 127 female and gender conversions respectively. So here you can see that it performs poor both gender than Akin which had this one had 224, 213. So 224 and 213. Female and male gender conversions respectively performs better. Okay. Oh, that's the insight. That's what you can obtain from that. Total approved conversions on audience interests. So this one I'm just going directly. So campaign audience, you can see the different audience of interest. And let's just go directly and plot a bar graph for that. So in audience interest, we have the business and industry, entertainment, that is games, entertainment in terms of reading. So when we compare in terms of business industry, again, you can see Akin 9326 performs the campaign ID Akin 9326 performs better in terms of when we are targeting the business and the industry. When we campaign the entertainment in terms of games, so the readers who prefer entertainment and games, again, you can see Akin 9326 performs better. When it comes to entertainment and reading, again, Akin 9326 performs better. So for the insights, you can say that Akin 9326 performs Akin performs better for all audience of interest. All. So they were targeting readers from this who prefer the business industry, entertainment, games, and entertainment in terms of reading. So when we were launching this campaign IDs, when we were launching these marketing campaigns, then we found that the Akin 9326 campaign performed better in terms of total approved conversions, that is. So it performs better in all three audience of interest. Okay. So again, we can see a key 9326 wins here. So here we say in terms of total approved conversions. We can also add another metric, cost-effective campaign, because this one is quite we can compare the cost effectiveness of the campaign of both campaigns. So campaign ID, cost per conversion, and see how the two are performing. So when it comes to cost per conversion, you can see that Aki 9326 has the highest cost of conversion. So despite the Akin 9326 having the best metrics in terms of total conversions, total approved conversions, total ad clicks, you can see despite us having that, it has the highest cost per conversion. So, so we are spending more, but we are getting more clients. And this one we are spending less, and we are getting we're getting less clients. So is there justification as to why we should use the 9326? So maybe based on this, we can now see if we can is there justification for that? Then maybe that the finance department can answer that question. Should we add another thing? So cost effective, cost per conversion. Let's see. Add expenditure, cost effective, cost effective. I think that's it. So we can go to conclusion. So for our conclusion, so what was our objective? So our objective was finding the best campaign based on total approved conversions. So we were successful with this, and so we saw that the best campaign was King 9326. It performed better in let me print the DF. You can see that it performed best in the age group category. In the age group category, audience of interest, and also gender. It, however, had the highest cost per conversion. Or that it is more. let's see. San Akin. Akin, it was Akin 8012. So for the conclusion part, because we need to determine which ad was best in terms of the metrics that we analyzed. So for my case, the objective was finding the best campaign based on total approved conversions. So after running the campaigns, what was the total approved conversions of the clients or the new book readers or the customers? So the best campaign was Akin 9326. When we looked at the different age group, and the different audience interest category, and the gender, we saw that it performed better in terms of that. Also, however, it had the highest cost per conversion. That means it was more expensive than Akin 812. So maybe the next thing will be about is it justifiable to now implement the Akin 9326? Though it's expensive, so if you implement it, are we going to get more revenues for that? So with additional data, and then we can analyze that. Okay. So that's it. That's it for today. So basically, you can see how we can perform an A/B test. So in this analysis, we were able to do an A/B test by testing the different campaigns, and we were able to answer our objective, which was about which campaign led to the more conversions. So despite that, we have also delved deeper into other types of metrics. So depending on uh, the 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 objective that you are handling, because when it comes to these types of analysis, when you're dealing with campaign, different types of campaign, then different types of campaign require different types of targets or goals. So you need to have a target and specify the target for the different campaign. So you need to have that in mind, and focus when doing analysis. Then you need to focus more on that. But for this was more of a generalized type, where we had different types of metrics, and we were able to see how these ad campaigns are performing based on those metrics. But I was when it comes to giving the final verdict, it was all about the approved conversion. Okay, so basically that's it for today. Once again, I'm very thankful for your time. And before we sign off for today, again, please consider subscribing to the channel. Welcome to this community. Hit that notification bell so that you never miss any of our updates. You can also give this video a thumbs up, and if you have anything to tell us, you can reach under the comment section, and we'll try as much to get back to you. Once again, thank you for your time, and until next time, see you in the next one. Bye bye.